Okay, hi, a very good day everyone. Today we are going to start off with our cubic polynomials and equations. So let's dive right in straight away. Previously we have learned from our lower levels on expressions and equations, and we wanted to categorize them to different degrees, alright? So for example, expressions of degree 1, right? Expressions of degree 1. Normally we call them linear, right? Normally we call them linear, and they usually will be in the form of ax plus b. Okay? So why? Because the highest power of x would be 1. Okay? Now then, sometime in secondary 2, we've moved on to objects or expressions with degree 2, and usually we call them quadratic. Okay, so what does a quadratic object look like? A quadratic object would look something like ax squared. Oh. Okay, so ax squared plus bx plus c, where a, b, c are constants. Okay, then now we can move on to 1 degree higher. Okay, so let's say if it's degree 3, these objects are known as cubic. Right, cubic, so cubic meters, like in terms of volume and so on. So over here we have our ax cubed plus bx squared plus cx plus d, right? So highest power of x is 3, and then it trails down to x power 0. So let's say if you're interested for further stuff, objects with degree 4, we call them quartic, right? Objects of degree 5, we call them quintic, right? And so on and so forth, right? So, but for now, we just stop at degree 3, right? So with degree 3 expressions and equations, we will need to know 2 big skills, right? So like quadratic equations, we need to know how to factorize them. We need to know how to solve them. So similarly for cubic polynomials and equations, we need to know how to factorize them. We need to know how to solve them, right? So this part is mainly about factorizing and solving cubic polynomials and equations, right? So without further ado, let us go to the first kind of factorization, which is our sum and differences of cubes. Okay, so our sums and differences of cube, usually we will follow this identity. So similarly to our quadratic identity, where we have our a plus minus b squared, right? It will give us something like it will give us something like a squared plus minus 2ab, and then plus b squared. Okay, and similarly we have our a plus b, a minus b. So this will give us something like a square minus b square. And for this one, right, it's actually known as the difference of two squares. Alright, difference of two squares. So for this one over here, we are going to look at the sum and differences of two cubes, right? And let's check out the identity of this one over here. Right, so here we have our a cube plus b cube, right? So we are interested, like for example over here, we want to transform it to a factorized form. So similarly, from a cube plus b cube, we can factorize this like this. So we can do it like a plus b, right? And then I have my a square minus ab plus b square. Okay, so instead of a 2ab, now we just have an ab, right? So this is how we factorize sum of two cubes. Okay, now what about the differences? The differences would be just a cube minus b cube, right? And then we have a minus b, and then we have a square plus AB plus B square. Okay, so we can use this identity to factorize sums and differences of two groups. So whenever we spot something of this form, we can factorize it to these two brackets like this. Okay, so now how do we remember, because that we have a lot of operation, right? So how do we remember which kind of operation to take note and so on? So let's take a look at each pair of operation. So over here we have this pair over here, right? We have this pair of operation. Now this pair of operation is the same, right? This one over here is the same as the original sum or difference. Okay, we have another pair of operation to look at over here. Okay, so this one would be your opposite or different, okay, because they are literally different different operation, right? Your plus minus and your minus plus. Okay, and the last one, this one is always positive. Okay, always positive. So an easy acronym to remember the order of operation, right, would be to use the SOAP. Okay, so same, opposite, always positive. Okay, same, opposite, always positive. Okay, so we can make use of this and then we can do our factorization. Okay, over here we are in page 80, try 14, and here we have our first attempt in factorizing sums and differences of two cubes. So first, let's take a look at A. So for A, we are factorizing 8x cubed plus 1. Okay, so first let's identify what is our A and our B. So here 8x cubed, A is just the cube root of this version, so 8 cube root would be 2, x cube cube root would be x, so A is going to be 2x, right? B, 1 cube root would be 1. Okay, so as long as you identify that 8x cube, the 8 is a cube, x cube is also a cube, the 1 is also a cube, you can use the sum of two cubes, the identity for the sum of two cubes. So over here, let us do the put in the frame so that we can fill in the blank later. So we are going to have our A plus B, right? A plus B, and we are going to have our A square minus AB plus B square. Okay, so take note of the signs over here, same, opposite. Now same as which one? Same as this one over here. Okay, so same, opposite, always positive. So okay, so over here we have our 2x, 2x, 2x for A. We have our 1, 1 and 1 for B. So to simplify this, we have our 2x plus 1. This is going to be 4x squared minus 2x plus 1. So there we go. We have factorized the first one. Okay, B. We are going to factorize now x cubed minus 8y cubed. Okay, so here we need to identify that this 2 is actually 2 cubes. So we have 8 cubed and 8y cubed. So 8 is also another cube. So what is our A? A is going to be just x. What is our B? 8 cube root will be 2. Y cube root would be just y cube root would be just y. So B is just 2y. So let's put in the order. So we have our A plus A minus B, so same sign. And we have A square, opposite, AB, always positive, B square. A bit too big, this one. Okay, so let's check our signs again. Same, opposite, always positive. Okay, same as which one? Same as the one in the question. Okay, so let's fill in the blank. We have our x, x, x. We have our 2y, 2y, and 2y over here. Okay, so let's simplify this. So x minus 2y, x squared plus 2xy plus 4y squared, right? 2 squared is 4, y squared is just y squared over here. Right, so here we have successfully factorized the sum and differences of 2 cubes. Okay, so the next part in cubic polynomials, which is to try to factorize our cubic polynomial. Okay, so over here in page 81, we have try 15, and here we need to factorize 2x cubed plus, minus 5x squared plus x plus 2 completely. Okay, so how are we going to do so? The method that we are going to use is to depend on our previous result in 4.2, which is actually to use our remainder or our factor theorem. Okay, so for a cubic polynomial, okay, so okay, so the next part over here, we are going to factorize our cubic polynomial, which is our next skill. Okay, now let us go back briefly to our list of polynomials and so on. Now let's take a look at the top one over there. Right, let's take a look at the top one over there. We have our linear term over there, right? Linear term. So how many solutions do we expect from a linear equation? Usually one solution, right? And the next one, we have our cubic equation over here. Wait, cubic expression over here. Okay, cubic expression over here. So how many roots or how many solutions do we expect? We normally would expect 2, up to 2 real roots. Okay, then what about cubic polynomials and equation? So the next degree will tell us the number of roots or number of factors that we can come up with. So we can come up with up to 3 roots or up to 3 factors. Okay, so over here we need to target to get out 3 factors from our cubic polynomial. Right? So without further ado, let us go back to this one. And how do we get our factors from our polynomial? So using the factor theorem, we will need to guess and check our first factor. So usually we need to guess and check the easy number. Okay, an easy number over here. So usually we will need to guess easy numbers like 0, 1, 2, -1, -2, half, 1/3, and that's about it. Okay, at most maybe you go 3 or 4, but you just need to guess and check the first root. Okay, so over here, let us quickly guess by guess and check. Okay, so by guess and check, so this one let me write in red because this is actually not needed. Okay, so by guess and check. Okay, so let's guess 1 as our root. So let f or let px be equals to 2x cubed minus 5x squared plus x plus 2. So this notation is going to save us time so that we don't have to write everything all over again. We can just use fx to represent this. Okay, so let's try 1. Right, let's try 1. So we're going to have 2 x cubed minus 5x squared plus x plus 2. Okay, so let's put in our 1 over here. Okay, so lo and behold, this is going to give us 0. Right, 2 minus 5 plus 1 plus 2 is going to give us 0. So what we've learned previously is by factor theorem, this is our this is going to be our root. Okay, so by factor theorem, this is going to be our factor. So by factor theorem, right, if x is 1, right, when you sub 1, so x minus 1 is a linear factor of fx. Okay, x minus 1 is a linear factor of fx. Now, so from here, we have two different we're going to go with two different methods. So let me show you the default method, but it's chunky, right? So the default method is how do we get the other factor. We will need to divide the x minus 1 out in order to get our other factor. So we are going to do our long division over here. So here, let's start off with 2x cubed. Okay, let me just write down method 1. Right, long division. Okay, so let's do this. So we are going to start off with 2x cubed minus 5x squared plus x plus 2. And here I'm going to divide by x minus 1. Right, so here let me divide this by x minus 1. Okay, this one is like, okay. Alright, so let us do some multiplication over here. So we have our 2x squared on top. So this is going to be our 2x cubed minus 2x squared. Right? So over here we will need to minus this part over here. So here we have our negative 3x squared plus x. So let me multiply by a negative 3x. So negative 3x times x will be negative 3x squared. Negative 3x times negative 1 will give us a positive 3x. Like this. Okay, so let us minus again. So over here we need to, so the 3x squared will cancel. We have our negative 2x plus 2. Okay, let's bring the plus 2 down. So last but not least, we need to multiply by negative 2. Right? So negative 2 times x will be negative 2x. Negative 2, negative 1 will be a plus 2. So because this is a factor, because x minus 1 is a factor, there should be no remainder over here. Okay, the remainder is going to be a 0. Okay, because it is a factor, it divides it completely, so we should expect no remainder, right? So if we see a remainder, means that we are careless at some point. Okay, so this is how we get our factor over here. So therefore our fx, right, so therefore our fx is going to be equals to our divisor x minus 1 multiplied by our quotient 2x squared minus 3x minus 2. Right? So this is the first method in breaking down the original polynomial, right, into the factorized form over here. Okay, into the factorized form over here. Right? So this is the first step in factorizing the polynomial. Okay? So let's look at method 2, which is actually to compare coefficients, and we see that we will actually get the same results over there. Okay, so method 2. Okay, so let us do some comparing coefficients. So I will need to make use of this one over here. So here fx is equals to 2x cubed minus 5x squared plus x plus 2. Okay, now because previously x minus 1 is going to be a factor, so I can express this as x minus 1, something of degree 1, multiplied with something of degree 2, so ax squared plus bx plus c. Right? Why? Because something of degree 1 multiplied by something of degree 2 will give us something of degree 3. Right? Something of degree 1 times degree 2 will give us something of degree 3. Okay? So over here, okay, let me write this down now. So this is degree equals to 1. This is degree equals to 2. The original one, the degree is equals to 3. Okay? Now, so here we have already broken down to the structure x minus 1 and another quadratic factor. So how do we need to solve for a, b, and c. But here we don't need to do like what we did previously. We can make smart guesses for a and c, and all we left to do is just to get our b out. Now, so let's make our smart guesses for a. Now over here, a, we can actually multiply ax squared and x to get our 2x cubed over here, right? So what would be a good number for a so that we can get 2x cubed? So a should be the number 2, because 2x cubed times x will give us 2x cubed on the left. Okay, so we can write this straight away. Right, the next one over here is for c, and when we look at the constant, okay, the constant on the left hand side, the 2, is actually made up of -1 times c. So what should be a suitable number for c so that we can get a positive 2? So -1 times -2 would give us a positive 2 on the left hand side. Okay, so we can make smart guesses for our a and our c. So what is left to do is just to solve for b. So for b, we will need to resort to comparing coefficients for either x squared or x, either x squared or x, right? So here we need to go with this. Okay, so let me remove this. Okay, so here comparing, okay, I'm just going to use x squared terms. So comparing x squared terms, right? On the left hand side, I will have a -5. Okay, on the left hand side, I will have a -5. On the right hand side, I will need to observe that my x squared term is going to come from this pair over here and this pair right here. Right? X times bx will be a bx squared, right? Then -1 and x squared, and 2x squared will give us a -2x squared, right? So on the left we have -5, on the right we have our bx squared and minus 2x squared. Okay, now in case you cannot see, right, on the left hand side is just -5x squared. On the right hand side, when we expand, is bx squared minus 2x squared, right? And we can remove the x squared and just compare the coefficients. Okay, so over here, let me just revert back to this comparing terms. So over here, -3 is going to be equals to b, right? So last but not least, we can express fx as x minus 1, right? 2x squared minus 3x minus 2, like this. Okay, so here we have two methods to factorize out the one linear term and one quadratic term over there. Okay, so both methods are the same. It's just that method 1 is going to be a long division, so it will look long. Method 2, we call this comparing coefficients, like what we did earlier. Okay, comparing coefficients. Okay, so our identity from previously. Okay, so we are not done yet. Let us double check and see whether does our quadratic factor, can it be factorized further. We need to factorize completely. So can this be factorized further? Okay, so over here it turns out that we can factorize further. Alright, so I'm just going to continue from the first one over here, yeah. So this one, when we factorize further, okay, when we factorize further, we are going to get something like x minus 1. We're going to get 2x minus, or 2x plus 1, and x minus 2. Okay, so this would be our final form of the factorization, right? So if we see a quadratic factor, we try to factorize it up. Okay, so similarly over here, okay, we have our x minus 1, and then we have our 2x plus 1, x minus 2. Right, so there we go. We have our final answer for our factorization of quadratic polynomials. Okay, alright, so alright, so let's take a look at our next example over here, try 16. Okay, so for our try 16, right, we want to find out the roots. We want to find out the roots for the equation x cubed minus 7x squared plus 15x minus y equals to 0. So over here, the skill now is to talk about solving the equation. Okay, so just now we've learned how to factorize, and from our factorized form, we already know how to solve this equation here. Okay, so let's take a look at what are the practical ways in how to get our first factor, right? So our so-called guess and check, because we have our calculator as our tool, right? So our guess and check, we can actually use our calculator to help this process. So let's take a look at our calculator over here. We can go into mode. Let's take a look at the equation. Okay, number 3 equation. 1, 2, 3, 4. 4 is the one that looks like a cubic equation over here. Alright, so let's go into 4. We need to key in the coefficients of a, b, c, d. So ax cubed, bx squared, cx, and d. So a is 1 over here. B is -7, right? C is 15. D is -9. Okay, so we have our cubic equation, the coefficients over here. So let's take a look at what are our expected roots that we should expect. Okay, so we have our first root is 1, second root is 3. Oh, first root is 1, second root is 3, and we only have 2 roots over here. Just nice. Okay, so for this question, right, let us guess and check. Okay, so-called guess and check that 1 is going to be our root. Okay, so let us put in by guessing and checking. Okay, so let us try with let fx be this first. So let fx be this polynomial x cubed minus 7x squared plus 15x minus 9. Okay, so x1 is 1. So let me put x equals to 1. So this is going to be 1 cubed minus 7 1 square plus 15 times 1 minus 9. Okay, so let me sub in the 1, and lo and behold, right, you can test your calculator again. You can go out and do some calculation, but it's going to be equals to 0. Okay, so because of our so-called guess and check, okay, this is going to form our root. So if x equals to 1, x minus 1 is going to be our root. So we need to write that by factor theorem. Okay, by factor theorem, x minus 1 is root of fx. Okay, so here I'm just going to go on and use the comparing coefficient because it's the shorter method. Okay, but by default, if you want, you can go ahead and do the long division. That will be the easier mode to handle. Okay, for me, I prefer shorter and more efficient method, so the comparing coefficient would be stronger for me. Okay, so over here I will have to express fx. I need to express it as x cubed minus 7x squared plus 15x minus 9, and I need to write this as x minus 1, and I'm going to have a quadratic factor over here. Okay, a quadratic factor degree 2. Same thing, I can do guess and check so that it will give me settle my a and c over here. So the first way to guess and check is to look at the x cubed term over here, right? So x times ax squared is going to be equals to 1x cubed, right? So what is a suitable number to multiply for a to give me my x cubed? Is going to be my 1. Okay, so it's going to be 1x squared. Now for c over here, I have a -9, right? So what do I need to multiply by -1 to get -9? So I need to multiply by 9. So c is going to give me a plus 9. Okay, so let me double check again. So x cubed, I have 1x cubed, and over here, okay, and over here I have -1 times 9 would give me a -9. Okay, so this is good. This is what I want. Okay, so the next thing to do is to compare coefficients of either x squared or x to give me my b. So comparing coefficients of x squared, or comparing x squared terms. Okay, on the left hand side I have my 15. On my right hand side, negative 1 times x squared will give me my x squared term. So this is the first term that I'll get. The second x squared term I'll get is b times x, bx times x. So I have a bx squared and a minus x squared. So over here I can write as a b minus 1 as the coefficient. Okay, if you really cannot see, on the left is 15x, sorry, on the left is 7x squared, negative 7x squared. Okay, so on the left is negative 7x squared. On the right hand side over here, I will have my negative x squared, right? And then have my bx squared, right? So it's going to be b minus 1 over there on the right hand side. Okay, so negative 7, yeah, so we're comparing x squared terms. So here, b is going to give me my negative 6. Okay, b is going to be negative 6. So therefore, my fx is going to be x minus 1, and I have my 1x squared minus 6x plus 9. Okay, now for the second, so here for the second quadratic factor, I can actually factorize it out to x minus 3, x minus 3. Okay, x minus 3, x minus 3. Okay, so just nice, because this thing is equals to 0, this thing is equals to 0. Okay, so now I can solve for my roots. Okay, so over here I have my x minus 1 equals to 0, or x minus 3 equals to 0, or x minus 3 equals to 0. So x equals to 1, x equals to 3, x equals to 3, like this. Okay, so I have 3 roots from this equation, 1, 3, and 3. Okay, but in our calculator just now, we only saw 1, we only saw 3, right? So this means that we have 2 distinct real roots. Okay, and over here the 3 is a repeated root. So technically speaking, we should have 3 roots. It's just that now we have 2 repeated roots over here. Okay, so for try 16, 3 roots, 2 repeated roots. Okay, so let's take a look at our next cubic equation. Alright, we have x cubed plus 5x squared minus 9x plus 3 equals to 0, and we need to solve it. So let us guess and check with our calculator and see what is our first root that we can get. So x cubed is 1, like the coefficient of x cubed is 1, coefficient of x squared is 5, coefficient of x is 9, coefficient of the constant is 3, right? So over here we have, oh, very weird. So this is a very weird number. We have 1, and we have another weird number. So with this, right, just now we can technically use either 1 or 3 for our first root. For this case, I think we will most definitely have to use 1 for our first root. So let's take a look at this one over here. Let us try and let us get 1 as our first root first. So let fx, right, equals to x cubed plus 5x squared minus 9x plus 3, right? Let this be equals to this polynomial first. So let me sub in 1, and same thing, guess and check. So here 1 cubed plus 5 1 square minus 9 times 1 plus 3. So put in 1, put in 1, put in 1. Indeed, it's going to give us 0. Okay, indeed it's going to give us 0. So by factor theorem, okay, because x is 1, so x minus 1. is a factor of fx. Okay, like that. Okay, so far we've got our first root out. Now, then I'm going to do my comparing coefficients, the method 2, shorter. I'm going to do my method 2 comparing coefficients to get my quadratic factor out. So I can express fx like this, so x cubed plus 5x squared minus 9x plus 3. So this is going to give me x minus 1 is a factor, and I have another quadratic factor over here. So ax squared plus bx plus c. Right? So what is a smart number for our to look at our x cubed term over here? Right? So ax squared times x would give me x cubed. So a suitable number for a is 1. Do you see this? Right? So 1x squared times x give me x cubed. X cubed. Now the next smart number that I can do is to look at the constant. So this one over here, the constant is going to come from this multiplication of these two terms, and over here my plus 3. So what is a smart number to put for c to get my plus 3? I can put in a negative 3. Right? So negative 1 times negative 3 will give me a plus 3. So there goes my a and my c. So what is left to do is to look for my b. So comparing x squared terms. Okay, or I can compare x terms. Why not I compare x terms now? Okay, so how do I get my x terms? My x terms will come from, okay, so on the left hand side will be negative 9x, and my x term will come from multiplying this one, so bx times negative 1. Okay, and my x term is going to come from this negative 3 times x. Do you see this? Okay, so the multiplication of these things will give me my negative 9x. So on the left hand side, I'll have negative 9x. On the right hand side will be our negative bx and minus 3x, correct? So because all of them are x terms, I can actually just compare the coefficients. So negative 9 equals to negative b minus 3. So last but not least, negative b is negative 6, b is going to be equals to 6. Okay, so solving for this, so therefore I can express my fx, okay, is equals to x minus 1, x squared plus 6x minus 3 equals to 0. Okay, so over here, right, whether can we factorize this quadratic factor any further? We can actually test out. Okay, we can go back to equation. We use our mode 3 from last time, so we can test our quadratic factor and see whether is it factorizable or not. So a is 1, b is 6, the c is negative 3, and lo and behold, right, it's like what we see just now, we get two weird numbers. So this signals to us that, you know, this is not an easy term to factorize. So what we can do is, let's break this out first and let us do some solving first. So we can write this as x minus 1 equals to 0, right? So obviously x is going to be equals to 1, as what we see just now over here. 1 was our root. Okay, then the next one would be the quadratic factor, okay, equals to 0. Okay, it's either this equals to 0 or that equals to 0. So the quadratic factor equals to 0. And over here, we will have to use our good friend, the quadratic formula, to solve this quadratic equation. Because we cannot factorize nicely, we need to make use of the formula to solve. So how do we do this? So x, right, we have a ABC. So x is equals to negative b plus minus b squared minus 4 AC, right, all over 2a. We can sing this song over here. So now let us write this insert form. Because we are AMath students, we will need to express this insert form. So we have a negative 6 plus minus, let me settle this one in the square root first. So we have our 6 squared plus minus 4, so plus 12. So we have our 48 over here. Right, so square root of 48, don't forget the square root now. So this is going to be 2 over 2. Okay, so for 48, we can we divide by 16? We can get a 16 out, right? So over here, we can split this to a square root of 16 and square root 3, okay, over 2. And just nice, square root of 16, I can change this to become a 4. Okay, so last but not least, I have a negative 6 divided by 2, so a negative 3, plus minus 4 divided by 2 is going to be 2. Okay, so over here my two roots are negative 3 plus 2 root 3 or negative 3 minus 2 root 3. So if we want to write it out fully, okay, if we want to write it out fully, we can do something like this. So or negative 3 minus 2 root 3. Okay, so first root 1, second root over here, third root over here. So 1 root, second root, third root. Okay, if you want to compress into one cert form, can, no problem. Okay, so these are our 3 roots, and lo and behold, you see negative 3, okay, negative 3 minus 2 root 3 is going to give us negative 6.464, which was our first root that we saw just now, the awkward number that we saw just now. Okay, so there goes the process of solving a cubic equation. So first, to recap, we will need to guess and check for first root, factorize out to first root and a quadratic, the first factor and a quadratic factor. Okay, then based on the factorization, we can solve. Okay, for this case is the second one is a quadratic factor that we cannot factorize further. Okay, so this one we will have to make use of our quadratic formula to solve our final two roots. Okay, now the very last question that we have right over here is try 18 in page 83, and over here we want to show that the equation, this equation has only one real root. So technically here we don't need to solve for the equation. Okay, we don't need to solve for the whole equation, we just need to show that the equation has only one real root. Okay, so we can do the same process, but at some point we can stop with the solving process and we can just go ahead and just show. Okay, so but we are going to start with the same process first. Okay, so let us do our guess and check first. Let us go to mode 3, 4, right? So that oh yeah, we have to set up our equation also. So over here we have our x squared plus 6 equals to 3x squared plus 8. So let me expand x cubed plus 6x equals to 3x squared plus 8. So we have our x cubed minus 3x squared plus 6x minus 8, right, in descending order of our powers, okay, to equals to 0. So we have a cubic equation, so we are ready to key in 1, negative 3, 6, and negative 8. Okay, so our root is 2, and over here, alright, the moment we see I is telling us that it's an imaginary number or it's a complex number, so it's not a real root. Okay, so x3 is another imaginary root. So here is 2. Okay, so let us guess and check 2 as our factor. So let us let fx be equals to x cubed minus 3x squared plus 6x minus 8. So f2 is going to be equals to 2 cubed minus this one plus 6 of this minus that. So put in the 2, right? And because this is a factor, your remainder is going to be 0, correct? And because of that, by factor theorem, right, by factor theorem, x equals to 2, so x minus 2 is a factor of fx. Okay. Alright, so let's get the quadratic factor out. So I can write fx as this. So x cubed minus 3x squared plus 6x minus 8. Express this as x minus 2 as one factor, and another quadratic factor ax squared plus bx plus c. So over here, let's take a look at what suitable numbers for our a and c again. So the coefficient of a is 1, right? So ax squared times x is going to give us 1. So a suitable number for a is 1. You see this? Okay. So first one done. Right, let's take a look at c, negative 8. So a suitable number for c, right, is actually coming from negative 2 times c, give us negative 8. So over here, suitable number for c would be a plus 4. Negative 2 times a positive 4 give us a negative 8. Okay, so done. We are done. So therefore, no, we just need to look for b. So comparing, okay, let's look at x squared term. Okay, so on the left hand side, we have our negative 3x squared. So on the left is negative 3x squared. On the right, we have bx times x, giving us the bx squared. Negative 2 times 1x squared give us negative 2x squared. So we have on the right hand side, it is bx squared minus 2x squared. Okay, and because these are all x squared terms, we just need to compare the coefficients. Okay, so negative 3 equals to negative b, it just equals to b minus 2, just like that. Okay, so here b is going to be equals to negative 1. Okay, b equals to negative 1, and because of that, therefore, fx is equals to x cubed, x minus 2, x squared minus 1x plus 4, right? And actually now this thing equals to 0. We need to solve for this. Okay, so over here, x minus 2 equals to 0. So x is going to be equals to 2. Okay, now, or we have our quadratic factor that we should not be able to factorize. It's going to be equals to 0. Okay, and how do we know that, there's no real root from this quadratic equation over here? So over here, we will need to make use of the knowledge from chapter 1. Chapter 1, how do you tell whether a quadratic has real roots or not? Discriminant. So let us test with the discriminant over here. Okay, so over here, our discriminant is going to be b squared minus 4ac. So b is negative 1, a is 1, this is 4. So I will have 1 minus 16 is equals to negative 15. And negative 15 is going to be less than 0. Okay, so over here for this one, there will be no real roots for this quadratic factor. Okay, so we don't have to solve for this quadratic factor. Instead we showed that this quadratic factor has no real roots. Okay, and because of this, the conclusion is x equals to 2 is the only real root for fx, or the whole equation, whole expression equals to 0. Okay, so let's take a look at our process again. It's the same as solving. It's just that at the end of the day, we show that there's no real root. So the first part over there is that we will need to arrange and form our nice cubic equation equals to 0. Second chunk over there, use the factor theorem to guess and check first root. Third chunk over there is to get the quadratic factor out to factorize. And after we factorize over here, we have 2 as our first real root. And over here, the quadratic factor equals to 0. There's no real root because the discriminant is less than 0. Okay, so over here we show that there is no real root for the second quadratic factor. Okay, so because of this, x equals to 2 is the only real root for fx equals to 0. So this ends our video for the whole portion on cubic polynomial and equation. So to recap a bit, for this portion we factorize cubic polynomial using SOAP or using our guess and check and comparing coefficient or long division. We solve cubic equations, okay, and we try to show that cubic equation has only one real root without fully solving the equation. Okay, so this ends our video for today. Have a nice day ahead.